Thanks for this opportunity to talk about what we were working on. And so I'm Ivan Booth, and
I'm Margot Kondratieva, and we are colleagues from math department, but I also teach for education.
so what we're going to do is I did a lot of the work on the curriculum, and then Margot worked on the study of how it was implemented and how it worked or didn't work. So I'm going to talk about the changes we made first, and then Margot is going to come in and talk about the rest of it. Now, let's go to advance. I don't usually use PowerPoint. Here we go. Okay, so our motivation. So this really focused on our course Math 2000. And I'll talk a little bit about its content on the next slide, but I guess a significant thing to understand about it is it's essentially unchanged since the late 1980s. So I know this because I took this in 1991, I think, or maybe 1990, and my sister took it a year or two before that. And it was exactly the same as it's basically exactly the same as it was then. So of course, one of the challenges that mathematics faces, I think, when we think about curriculum change, and maybe physics as well, is that math and physics don't really change. And what we teach our undergraduates in the first few courses, is stuff that has been known for, some of it has been known for like 400 years, but it's still basic stuff you have to know. So it's easy to fall into the feeling that things don't really need to change because math is all the same, right? And I think that's one of the reasons it's gone so long before we had another look at the curriculum. But of course, while math maybe hasn't changed, the world's changed hugely around it. So one of the things that happened is, of course, technology has advanced incredibly since then, and that provides a lot of opportunities and challenges. And I'm going to focus on that kind of quite a bit now in the next couple of slides. Another thing that's happened, though, is our audience and our likely careers have changed. So back in the 80s and the 90s, probably most of our audience in one of these courses was math students who were hoping to be teachers, I think. I mean, we're a huge chunk of it. That number is much, much smaller now. And now our largest number are probably computer science students. So there's been a shift in who the audience are. There's also been a huge shift from, of course, the math curriculum in the schools has changed since then. And there's been a big shift to international students from students who went to school in Newfoundland. And so we need to kind of think about how these things change. And also we want to encourage people to take further math courses. So we want to keep our math relevant and attractive. Okay, so I know most of this audience isn't a mathematics audience. Maybe no one is except me and Margot, I'm not sure. So I'm just going to talk really very briefly about the content of the course, and then we're going to really kind of talk mostly about how the technology works in it. So the course is kind of traditionally in two pieces. There's one on infinite series, which is a way of writing functions in terms of infinite sums. And the second bit is multivariable calculus, which is sort of working with functions of two variables, finding maximum, minimums, understanding shapes of surfaces, these kinds of things. So it's a very standard course that is offered in, like, any university would offer this course or versions of this course, or maybe this material in other courses. That's probably a bit more accurate. And it's taken by computer science students, majors, chemistry majors, math, stats, physics, and ocean and naval engineering students. And as I said, I think we're pretty confident that the largest number now are the computer science majors, whose numbers have been exploded in the last few years. The class sizes are sort of 70 to 90 people. We usually offer 2 sections of this in the winter, or in the fall, 2 sections in the winter, and one over the summer or the spring semester. So these are, by the department sizes, these kind of, I guess, medium-sized courses, right? I mean, it's not like our huge first-year courses, but they're still at the level where there's quite a lot of students in them. Okay, so this is what I'm billing kind of as the maths ChatGPT moment of a few years ago. So a few years ago, a threshold was crossed. And so, lots of people have done Math 1001 and maybe had bad memories of it from years ago. So nowadays, for about 30 years, 40 years, it's been possible to solve most of the things you'd see in a first-year math course using a computer. But about 3 or 4 years ago, we crossed a threshold where instead of having to type these things into a computer, which was a big barrier for a lot of people, they could just take pictures of them instead. And so this is a screenshot from Photomath, which is maybe the best known of these systems, but there's lots of others as well. So if you have any integral or any derivative, or many other math problems, all kinds of high school math problems, simplification problems, adding fractions, anything like that, you can pull out your phone, open the app, take a picture of it, and it doesn't even need to be typewritten. These can be handwritten problems, and it'll give you the answer immediately. And as you can see, there's kind of a steps button as well. And if you hit that steps button, it will then give you all the steps. So this is pretty tricky from the point of view of traditional assignments that we used to do in math courses. And we used to get lots of assignments to get people to get the practice, because now if they want to, they can just take pictures of them, copy everything down. This could be a good thing because they could, well, I mean, copying them down and not thinking isn't a good thing. But this technology can be useful because it can help them understand things. But it also means that any marks you're giving for assignments are pretty suspect. People, of course, have had friends help them and all kinds of things for years and years, but this makes it very, 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 very easy, right? It's equivalent to, like I said, it's kind of the ChatGPT moment of that students are going to be using it, writing your essays with ChatGPT. We know that they'll be using these in homework problems. But it also brings up another question that we're not going to answer in this, and I think it's a bigger question, is once things become trivial, how much do they really need to know of them, right? I mean, it's trivial to use the computing, using their phone even to solve these problems. So how much of it do they need to know to do by hand? There's obviously some of it because, the process of doing things by hand is a learning in itself, which helps you learn for bigger problems and more complicated things that you can do later on. But, things have changed there. Maybe just a little anecdote about this is one of the things in Math 1001, which people traditionally find difficult, is something called partial fractions. During COVID, when we were having online exams, even though they were being proctored, magically, like about 10% of the class could suddenly do partial fractions, which people have always had problems with. They could do partial fractions apparently in their heads because they would just write down the answer right after the problem on the exam. So we knew that at least 10% were probably cheating, and probably like 20 because there's some who have been cheating in a cleverer way. So there's a question there about what you need to know in this situation, but we weren't going to really address that. So that's a challenge, maybe, but there's also opportunities here. So you could be using those programs to learn things, right? You could be saying, well, I don't know how to do that problem. I don't understand the steps. Can you help me with it? And then the computer and your phone could do that. But there's also other opportunities. So if you go back a couple of slides to that picture of the three-dimensional surface, plotting three-dimensional surfaces when I took this course back in the early 90s was basically impossible, right? You could struggle for a long time and get some vague feelings, and that's about, you could do it. Or plotting curves. You may remember if you took first year math, spending a lot of time plotting curves. Now these things are essentially trivial. Using either the system I just showed, you can do it, I think, but also other kind of other technologies can do it. And you can just look at surfaces. That surface I showed you, that was a screenshot, but you can rotate that in space, look at it all different angles, really understand it. And one of the things that's opened up with this is by having some things that were sort of kind of algebraically or kind of computationally difficult, which are now become easy, you can learn this to build experience and to explore problems and look at many more difficult problems than you would normally. In a lot of these first and early math courses, there's actually a very limited range of problems you can ask people because there's only a very limited range that can be solved easily by hand. If you have if you start using computers to help you out, then you can look at a much broader range of problems. And this is, I think, how many slides? I'll talk a little bit about what these systems are now in the next couple, but we'll come back to that now. The other thing that's a big issue now is, of course, when people finish their math degrees, math or stats degrees, then if they have computer skills, it's pretty easy for them to get good jobs. If they don't have any computer skills and they're scared of computers, then they don't have such great job prospects, right? And so we kind of really feel it's a responsibility to improve the computer skills of our majors. Okay, but now there's other challenges. So just like people have math phobia, it's pretty clear that, and I've done this stuff in other courses as well before this one, that a lot of students have a computer phobia. So they talk about kind of coding, which is a very general term they use, which basically means anything you do on a computer that doesn't involve using your smartphone. And so there's a lot of students who are very afraid of it. And of course, there's some students who learn these things easily and some students find it much more difficult. So whenever we introduce technology in a course, we'll have a lot of students who are kind of pretty worried about doing that. Even just installing software can be quite difficult for some of them. Some of these students will just think of, well, it's another thing to learn. If I wanted to do computers, I would have done computer science. I don't want to do computers, so that's why I took this course. There'll be some students like that. And these people will often kind of not appreciate the big picture that, really this is part of, what they need to, get jobs later on. It's not just a distraction. It is like, we're doing it so they can help learn, they help explore and help learn the mathematics, but it also has the thing where it's giving them useful skills. Okay, so this is my last slide, then I'm handing over to Margot. So our restructuring plan was that there are these general computer-based general systems called computer algebra systems, which will do algebra for you, right? That's all those things that you remember from high school. You can automate them. It's not just doing stuff with numbers. You can do it with algebraic expressions as well. They'll plot surfaces. They'll solve differential equations. They'll calculate numerical integrals. All kind of basically, this is command line, sort of command line stuff, right? You're typing things, but it's not really programming. It's just like a bunch of commands that do things. You can program in them, but you don't have to. So the one that we chose to use, the commercial systems that some people may know about are Maple and Mathematica, and to a certain extent MATLAB. But the one we chose to use was SageMath, which is an open source, so it's free for the students to use. It has web-based versions and versions they can install on the computer. But another kind of big advantage from our perspective of giving our students useful skills is that it's Python and Jupyter-based. So it's basically written in Python. And so if you're doing stuff, you're using Python syntax, which is useful because Python's a language that people will ask them would they know anything about, and it runs in a Jupyter notebook, which is where most modern things run, as opposed to the commercial systems, which have their own things that they run. So what we did is we spent 5 classes introducing it. So for students who are really comfortable with computers, they find this very boring. For students who are pretty worried about computers, this is probably not enough, but this was our compromise. And then we get them to use it on assignments, and then we don't have them using it on exams or tests. That's a point that has been discussed, but we're not doing it at the moment. And then we also introduced a project into the course, which is kind of unusual for a second-year math course, I guess, or for this calculus course, where they use SageMath to explore some more difficult problems. Because one of the goals is, like Margot will say, is we wanted them to be exploring things. And then we had them submit a video of their project. So we had grouped them work in groups, and we had them submitting videos. There's also changes to the curriculum, which I haven't really spoken about. But so maybe there's a bunch of new material got brought in to try to make the course a bit more relevant for later courses and for them to see kind of some of the more exciting things in mathematics in this second-year course. So it's not just like going through learning basic techniques, but see previews of some future things. And also I mentioned there's 2 pieces of the course. The traditional version, these are just like completely separate. It's like having 2 short courses. And then with the changes, we kind of brought them together. But maybe that's what I'll say about the curriculum. Okay, Margot, take it away.
Okay, thank you, Ivan. So I should say a few words about how it all went. I taught this course myself several times in the old version, never tried the new one. We had a number of discussions with Ivan and other colleagues who also taught the course. So we all made the planning. And because I'm working in both education and science and mathematics, it was probably most natural for me to do the observation, to be sort of like Karen was, a critical friend, right? So I went for several lectures, or rather I watched some videos, not to interfere, right? I watched searched recorded videos online. And we also interviewed students in the end, and we had several surveys during the term. So there were 2 sessions, 92 students and 80 students, respectively. Ivan and another professor, Turun Shir, taught the course. So that's the observation methodology. Okay, next slide. So what we found in at the beginning of the term, that the majority of students use technology, and as it was expected, 100% had a smartphone, 98% used laptop. With desktop was also a lot, but not as much. They said 92%, they said, enjoyed using these technologies on daily basis. And they were also thinking that being able to use technology is important, 90%. And many believe that using technology saves time. So when students said we use technology, mainly they thought we use them for communication, like checking emails, social media, messaging, communicating with friends, work-related and just fun-related. They were searching information, again, mostly on Google, then Wikipedia, YouTube, ebooks. Funny enough, they said lots of them never been to the library, but many students said they were reading ebooks, even though they preferred actual books. But anyhow, so next slide. So in terms of some statistics in this particular setup, 71% of the students were computer science students. So there was relatively natural to use some elements of computers, given that they use technology. Many of them are computer science technology. 36% of the students used actually programming software to help previous mathematical courses. This is course at 2000 level. Usually students also have at least 2 calculus students before, at least 2 calculus courses before this course, but also maybe other courses. So it's not, it's very much not the first experience with a math course. And as we see here, some students already were using some software. Many students, 83%, used equation solver websites or graphing calculator, including online graphing calculator. 55% used smartphone apps and photomath, which Ivan mentioned, where you can just take a picture, send it, and in a few minutes get the full solution without even knowing how to write down this, symbols. It's amazing. So we were trying to sort of beat this experience with using technology in a wrong way in our perspective, and giving them, a better technology which helps them to understand and make sense of the material rather than just, receive the answer and receive a grade. Okay, so let's see what happened next. So I'm only, with the interest of time, I'm only given some data we collected, discussing them here. In the midterm, we asked, so there was some, resources obviously given, how to use Sage, examples were given. But anyway, when you do actual problems, sometimes you get stuck. So if you don't know how to use Sage to do particular assignments, what do you do? So the most popular response was that I go and search online. Okay, but surprisingly, the second popular response, I just skip the problem, right? So, I can't do it, I skip. And this is despite the help was available. So instructors were having, office hours. Ivan was sitting in the help center. And
we had a Slack channel.
Yeah, okay. You had slash. Yeah, exactly. So students would probably use the channel to talk to their peers, and only 20% actually went to a prof to ask the questions. They would, this raises many questions. This study about students' habits in general and their goals and their, overall perceptions of what is a math class and what do you do to succeed in a math class. But anyhow, let's see what else we collected from students. So there were responses, and I just tell you what students felt of why this computer algebra system Sage Math was helpful. So visualization, especially visualization in 3 dimensions, was overwhelmingly the winner. Right? So definitely visualization is there. Students also were given examples, and they related to them that this is a quick way to use differentiation, integration, algebraic simplifications, and self-check. So some students said that in comparison to other online calculators like Symbolab, Sage is more powerful. Some others will come with no answer, and the Sage would give the answer, which is a good thing. And what is pleasing that some students were, studying for a midterm, and they were verifying their work with Sage, which is one of the uses we wanted them to actually, engage in. Okay, so there were obviously unsatisfactory aspects with some students. So Sage Math or Python, which is base for Sage Math, will not be on the final. So why we are doing this? So this is a very typical question in many respects, not only about Sage Math, like why we are doing something this is not on the final. So in a way, Sage, we couldn't do it on the final on probably technical reasons, but we incorporated Sage in assessment in a way of a project. But since we're still thinking of the final as the main piece of assessment, some students felt it's time consuming at the beginning. In particular, it's a free software, so it has more difficult installation and the beginning of the learning of the syntax, a limitation of resources online. Even though examples were given, but when you start doing it, you might feel like there are limited resources or examples. And several students expressed concern that we are taking fresh, the new topic in the course, and simultaneously we learn something new in terms of computer software. So they felt like the time is not distributed between that and that. Okay, so what about student suggestions? Again, there were a range of suggestions. Students who already were equipped with computer science knowledge, they welcomed this new opportunity. They related to the fact that we're trying to do something to their benefit, to improve the course, and related to more, modern and demand of the life. So they said, I encourage use of Sage Math in the course, helpful for visualization, understanding what's going on, especially for computer science students who already know Python. But then there was a completely opposite, suggestions, let not use it because it takes time from learning the course material. And there was maybe next slide, there was a suggestion saying that we actually need a separate course where we focus specifically on software and maybe not only on Sage Math, but also on Excel and PowerPoint, something which prepares us for real for jobs, but it will be not, and maybe that's an interesting suggestions too, but it requires, more attention and more discussion in the future. Okay, so there are a couple of things from the interview. So my thing was that I thought, like, I should probably say it up front that mathematics now, equipped with computer algebra system and dynamic geometry software and things like that, is considered basically equivalent to an experimental science. So you can, with mathematics, you can observe the patterns, create, hypotheses, prove the hypothesis, etc. So that's the part what mathematicians do, and that's like with this software available, we can share this experience with students as early as at calculus courses, and they can also get all this sense of mathematics being creative and being, part of experiment, etc. So, and I asked explicitly students who did the interviews, did you feel like you are more creative with Sage Math? So one student said, I tried to plot different functions, lots of functions from my back. I didn't know how they look like. Not that much experiment, but I just looked how things look in 3D. So I think this is already a big plus, right? So he didn't know, he never thought of a possibility of plotting 3D shapes, and now that was in his hands. So he could be, asking his own questions and answering them. Another student said that I hadn't really experimented with this because mainly I don't have enough knowledge, and so that is another thing, that maybe students aren't yet at the stage where it can fully experiment with the software, and that also brings us to maybe we think about more about how this curriculum laid out, etc. Okay, and maybe the last slide for me. So in the end, we asked students to confirm or disconfirm that, again, talking about creativity, I can be creative in math, or Sage Math makes me better equipped to solve mathematical problems. And we were happy to see many students who agree, but in a sense, it was unfortunate that there was balanced with the numbers of students who disagreed. So there are different, scenarios in that. But it was encouraging to see in the project, we actually saw evidence of their creativity. And unfortunately, we can't showcase mathematical creativity as easily as it was done in the first talk, for example, in engineering. It was like creativity here means a little bit more deeper mathematical knowledge, but it was encouraging. And maybe Ivan, who taught the course, maybe in the last couple of minutes you can comment on that if you wish.
Yeah, so I guess maybe I'll just say, I think we're over time actually, but just very quickly, with those projects, we did see so for this first offering, we randomly assigned people to groups to work on projects and work on different types of projects. And so we had a good test there. And we did see evidence, well, reasonable evidence, that people who worked on a particular project in an area then did better on the corresponding questions during the exam. So that was good. Okay, I think that's it.
Okay, but that's all at the stage yet. Probably we need more offering and more observations. So we're looking forward to more experiment with this material. Thank you for your attention.
Thank you very much. There is one question over in the chat. Not sure if you saw it, but was the overall course average for the course higher as a result of incorporating Sage Math based on the history of the course?
Yeah, so it's a good question. So we also changed the evaluation scheme. We also changed the material in the course, right? So I would say, yes, it was higher, but whether that was a result of the Sage Math I don't think we can really say. This semester, it was higher again, but of course, because of the strike, we cut out some material, including one of the hard topics. So Yeah, so I don't know. Yeah, we would hope to see something dramatic there, but it's really hard to know what it would be.